today we're going to be learning about the distributive property. And to get us started, I'm going to kind of relate this to real life so that you understand exactly what you have to do instead of just jumping right into numbers. So if we come over here, I ask the question, what does it mean to distribute? If I was distributing something, it would mean like I was passing out food or shaking hands with everybody at a party. I'm distributing my handshake, or I'm distributing food. For these real-life examples, I have chosen to use shaking hands with everybody at a party to explain the distributive property. Remember, with the distributive property, we have to be fair. So if I had this bag of animal crackers and I had 3 people that I was with, what would be the fair thing to do? The fair thing to do would be to dump this same amount of animal crackers on every single plate. Okay? I wouldn't think it was fair if somebody had more than me, and they wouldn't think it was fair if I had more than them. Okay, so let's just say we are having a costume party. At the costume party, Davis decides to dress like a dinosaur, so we're going to call Davis D. We have one other guest named Bree who decided to dress like a ballerina, so we are going to call Bree B. Since the 2 are already at the party, they are inside of the house. You'll notice that I'm representing the 2 of them inside of the house by putting D, dinosaur, plus B, ballerina, within parentheses. Because they're inside of the parentheses, that means they're already at the house. But then, there's a knock at the door. Madigan, dressed as a mummy, we'll call him M, wants into the party. Do you see how the M is outside of the parentheses? He wants in. The only way for Madigan, the mummy, to get into the house is for Madigan to shake hands with everyone in the party. If he leaves somebody out, he's not in the party. So I'll show you that over here. So the first thing the mummy has to do is shake hands with the dinosaur. So the mummy shakes hands with the dinosaur, which is represented over here. Then the mummy shakes hands with the ballerina, which is represented over here. Now right here we show in letter form the 2 shaking hands. Since there was a plus sign in between, we're going to keep that plus sign in between. So Madigan's allowed in the party because he shook hands with the dinosaur, plus he shook hands with the ballerina. So now, magically, the house grew a little bit, and all 3 of them are inside of the party, represented with M plus D plus B. So the 3 are at the party, and there's another knock at the door, meaning somebody else wants into this awesome Halloween party. Uh-oh, it's Miss Sullivan. We're going to call her S. Notice she's dressed like a bride, since I'm going to be a bride soon. So if I wanted into the party, what would be the only way for me to get in? If you said shake hands with everybody, you're absolutely right. Now it doesn't matter which order the 3 are in, as long as I'm shaking hands with everybody. So first, I decided to shake hands with the mummy, which is shown right here. Second, I decided to shake hands with the dinosaur, right here. And third, I decided to shake hands with the ballerina. Now, it doesn't matter the order, as long as I'm shaking hands with everybody. So if I were to show this in terms of numbers, I'm going to constantly refer back to this whole costume party. So if we look at the first example, who's outside of the party that wants in? We've got a 2 right here. So the only way for the 2 to get in is to first, the 2 is going to shake hands with the 3, plus then the 2 has to shake hands with the 9. In order for this to work, the 2 has to shake hands with everybody. A handshake is represented with multiplication. I think of the fact that the hands are like crisscrossing, which reminds me of multiplication. So this would give me 2 times 3 is 6, plus 2 times 9 is going to give me 18, which gives me a total of 24. Now I can add these two together because they're both just numbers. I can add 6 plus 18. Eventually we'll get to variables where we're not able to combine the two together. So if we look here, we have 5 on the outside of the party. So first the 5 is going to shake hands with the 4, plus, because there's a plus sign, now the 5 is going to shake hands with the 7. So 5 times 4 would give me 20, plus 5 times 7 would give me 35. If I added the two together, I get 55. Now the reason I chose to use numbers in this first example is so that we could check with the order of operations. The order of operations would actually ask us to do what's in the parentheses first, which would leave the 2 on the outside, and then 9 plus 3 would give me 12. And 2 times 12 does give me 24. I just wanted to show you that it does work the other way, but we don't always have numbers in there, so we're not always able to add the two together. If I were to do this one with order of operations, I have the 5 on the outside and the 11 on the inside, and 5 times 11 is 55. So when we get over here, you're going to notice that it's slightly different. We still want to ask ourselves who's outside of the party and how do they get in. So in this case, there's a 2 outside of the party, and the only way for the 2 to get in is to shake hands with everybody. So the 2 is going to shake hands with the A, plus the 2 is going to shake hands with the 9. 2 times A is 2A, plus 2 times 9 is 18. Now many students think that they need to take it further than this, but we cannot combine these two together because one of them has an A and one of them does not. On the next example, you're going to notice it looks slightly different, and that's because the person that wants in the house actually came to the back door instead of the front door. But that's totally okay. We would still be able to allow somebody into our house through the back door if that's the way that they chose to come in. So the 4 wants into the party. The only way for the 4 to get in would be to shake hands with both people at the party. It doesn't matter the order. So we could say the 4 is going to shake hands with the 4 first, plus then the 4 is going to shake hands with the C. As long as the 4 is shaking hands with everybody, we're good to go. 4 times 4 would give us 16, and 4 times C would give us 4C. We do not need to take this any further. We cannot figure out what C is because there's no equal sign. Okay, so now we're going to do the same thing. See who wants into the party. The 5 wants into the party, and to get in, the 5 has to shake hands with everything on the inside. So the 5 is going to first shake hands with the 2x, plus the 5 is going to shake hands with the 5. When 5 shakes hands with the 2x, we just think of first 5 times 2, which is 10, and we still have that x. So 5 times 2x would be 10x, plus 5 times 5, 25. We cannot combine these two together because one of them has an x and the other one does not, so we have to leave them separated. On the next example, you'll notice that somebody came to the back door or the side door, however you want to look at it. Still, the only way for them to get in is to shake hands with everybody. So the 3 has to shake hands with the 2, plus the 3 has to shake hands with the 10b. 3 times 2 would give us 6. Plus 3 times 10b, remember, just think of the numbers first. 3 times 10 would give us 30, and then we still have that b. Now we cannot combine these two together for the same reason as before. One of them has a b and one of them does not, so we leave them separated. So in class I had everybody try these ones on their own. Again, you're still asking yourself the same questions. So on this first example, the 7 wants in, so first the 7 shakes hands with the y, plus the 7 then shakes hands with the 3. 7 times y gave me 7y, and 7 times 3 gave me, sorry, that should be a plus sign, 21. Let me just kind of erase that bottom part there. Because there was a plus sign in the middle, that's why there needs to be a plus sign here. Here's our final answer. Now the next one might look kind of different to you because you notice that there's a minus sign. It doesn't change anything except for the fact that there's going to be a minus sign in your final answer instead of a plus sign. So when I go here, I've got 8 shaking hands with the M, minus 8 has to now shake hands with the 1. 8 times m is going to give me 8m, and 8 times 1 will give me 8. On the next example, you're going to notice that the 5 wants into the party, so to get into the party, the 5 is first going to shake hands with the 4x, it's a minus sign, then the 5 is going to shake hands with the 5. 5 times 4x, think of 5 times 4 first, which is 20, we still have our x, minus 5 times 5, 25. The last example here, the negative 9 wants into the party. Don't be alarmed by the negatives. You know the rules for our negative numbers. So first, the negative 9 is going to shake hands with the 4. Plus, now the negative 9 is going to shake hands with the 2n. Negative 9 times 4, just think of 9 times 4, which is 36, and there's still that negative sign that we have to bring with it. Plus, negative 9 times 2n, think of 9 times 2, it's 18, plus we still have that n, and we still have that negative sign. There's our final answer. Again, a couple more examples. In this one, the 5 wants in. So we have 5 times 6y plus 5 times 1, meaning 5 shaking hands with the 6y, 5 shaking hands with the 1. 5 times 6y is 30y, plus 5 times 1 is 5. Now we are eventually going to factor out this middle step, but I like to see it written down so that if you were to make a mistake, I could correct your mistake. So on the next one, we have 4 times 2x. Be careful because it's a minus sign. Then we have 4 times 5. 4 times 2x is 8x minus 4 times 5 is 20. Okay, now we've got a negative number on the outside. So we have negative 6 times 2n and negative 6 times 4. And it's a plus sign in between. Negative 6 times 4. Negative 6 times 2n is going to give us negative 12n. Remember, it's just like 6 times 2, which is 12, and we still have a negative sign. Plus negative 6 times 4 would be negative 24. Now the next one is where we run into a couple different problems. So what I'm going to ask you to do is, because we see two negative signs here, I'm going to go into my n minus 8 and I'm going to keep it, change it, flip it like we learned with our subtraction. So when the negative 3 wants in, the negative 3 is going to first shake hands with the n, and now it's a plus sign. Now the negative 3 is going to shake hands with the negative 8. You'll notice that when the negative 3 shakes hands with the negative 8, we have two negatives, which is a positive. So let's figure out our answer. Negative 3n plus, and these two negatives as a positive give us a positive 24. This type of problem gives many students a very hard time. So you want to make sure that when you have two negatives that you keep it, change it, flip it so that you can see that it becomes a positive. So we've got a couple more examples like this. You'll notice we have the two minus signs, so I'm going to go through and keep it, change it, flip it on both of these. So now the negative 8 wants into the party, so the negative 8 is going to shake hands with the 9x, plus the negative 8 is going to shake hands with the negative 3. So we have negative 72x plus 8 times 3 gives us a positive 24. Two negatives gave me a positive 24. The next one, the negative 2 wants in, so the negative 2 is going to shake hands with the negative 4n, plus now the negative 2 is going to shake hands with the negative 4. So you'll notice here we have a negative and a negative, which is a positive 8n, and a negative and a negative, which is a positive 8. Okay, this part sounds a little bit confusing, but you'll understand how we're going to use this when we start plugging numbers into equations. So if I had the number negative 4, what would I be multiplying by 4 to get that? It would be a negative 1, because if you look at this, negative 1 times positive 4 would indeed give me negative 4. So now this next problem, we say the opposite, that arrow isn't really turning out so well, the opposite of negative 7. In order to get the opposite of negative 7, we'd have to do negative 1 times negative 7. The two negatives here would make it a positive. The two negatives here would make it a positive. So therefore, if we have a negative sign outside of a set of parentheses, it's just like if we had a negative 1 to be distributed. So if you notice here, who wants into the party? It would be the negative sign. So the negative sign is going to shake hands with the 4x, plus the negative sign is going to shake hands with the 5, which just gives us the opposite of what we had before. But if that part is confusing because it's not a number, you can always substitute in a negative 1 and have it be negative 1 shaking hands with the 4x plus negative 1 shaking hands with the 5, which would still give us negative 4x plus negative 5. Either way works for me, however works best for you to remember. Okay, now students have a tendency to get alarmed when they see fractions. I want you to realize right now that you already mastered your fractions. We did that last week. So we want to just keep in mind the process of the distributive property and what we remember about multiplying fractions. So when I look here, who wants into the party? Well, the 2/5 wants into the party. So the 2/5 is going to shake hands with the x, and it's a minus sign. We have the 2/5 shaking hands with the 2. But if we remember our rules about fractions and whole numbers, you'll notice that x isn't a fraction and 2 isn't a fraction. In order to make them fractions, we have to put them over 1. So I'm going to do that right now. Then we just have to remember our step-by-step process of multiplying fractions. You remember the song, multiplying fractions, no big problem, top times top over bottom times bottom. So we go here, top times top would give me 2x over bottom times bottom would give me 5. So I did 2 times x, 2x, 5 times 1 is 5. Bring down my minus sign. Now I'm going to do top times top, 2 times 2 gives me 4, over bottom times bottom, which gives me 5. Now, I cannot go any further. Even though you notice that they have a common denominator, the reason I can't go any further is because the term on the left has an x and the one on the right does not. So I am done with this problem. I don't have to do any more work. Looking at the next one, you'll notice that the negative 3/4 wants inside. So the negative 3/4 needs to first shake hands with the 2x, plus the negative 3/4 needs to shake hands with the 1. Now I need to make both of them fractions in order to follow out my multiplying fractions. So negative 3 times 2x is going to give me negative 6x over 4 times 1 gives me 4, plus negative 3 times 1 is negative 3 over 4 times 1 is 4. I would accept this for an answer, or if you acknowledged that this first fraction can be reduced by dividing the top and the bottom by 2, I would also accept negative 3x over 2 plus negative 3 over 4. Now on this part, what we're going to be doing is the same exact process. All that's changing is that we have some decimals. So if you look to see who wants in, it's our 2.6. In order for the 2.6 to get in, the 2.6 needs to shake hands with everybody in the party. So 2.6 is going to shake hands with 7.35, plus the 2.6 is going to shake hands with the 0.8x. So off to the side, I'm going to multiply 7.35 times 2.6. Ignore the decimals for now and just go ahead and multiply. 6 times 3 is 18, 19, 20, 21. 6 times 7 is 42, plus 2 is 44. I add in my placeholder. 2 times 5 is 10, so I'm going to put my carry. 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14. Add them up. And I notice that in my original problem, I have 1, 2, 3 digits past the decimal. So I'm going to go 1, 2, 3 digits past the decimal, which that's going to give me 19.11. I do not need to add in the 0 because it's just a placeholder there. It would mean the same thing no matter how many zeros I have. So I'm going to go ahead and erase this work so that now I can multiply 2.6 times 0.8. So 2.6 times 0.8, again, ignore the decimals for now. 6 times 8 is 48. 8 times 2, 16, plus 4 would give me 20. And I have two digits past the decimal, so I've got plus 2.08, and I can't forget that over here I still have my x. There's my final answer. So there's really no difference in these except for sometimes students get scared of the decimals. Don't be frightened, you know what you're doing. Just have to go through this step-by-step process. So when I come over here, I'm noticing I see lots of negatives. So I'm first going to keep it, change it, flip it so that it doesn't throw me off. So now the first thing I'm going to have to do is the negative 1.5 is going to shake hands with the negative 3.01x. Plus the negative 1.5 is going to shake hands with the negative 2.5. So now I've got to do 3.01 times 1.5. 5 times 1 is 5, 5 times 0 is 0, 5 times 3 is 15, placeholder 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 3 is 3, add it up, and there are 3 digits past the decimal, so a negative and a negative give me a positive 4.515, and this one has the x with it. I'm going to go ahead and erase my work. And now I've got to multiply 1.5 times 2.5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Placeholder 0. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. 5, 7, 3. 2 digits past the decimal. So I'm going to put plus, and a negative is a positive 3.75. Okay, so we're going to extend this into what type of word problem could be created using the distributive property. So first I want to review area. So with area, we need to remember that it's going to be length times width. So if I asked you to find the area of this, what we could do is just take our length times our width. And that would give me 50, and since it doesn't give us a unit, I'm going to just write 50 units squared. Remember, our label when it comes to area is going to be units squared. On the next one, we have to multiply length times width, which is going to be 13 times 9. And what I told you in the past is to break up this 13. What I do is I break the 13 up into 10 plus 3 in parentheses, and then I'm going to multiply that by 9. If you notice the way that I set this up, it's the distributive property. In order to figure this out, just like I've told you in class, I would do 9 times 10, or 9 shaking hands with the 10, plus 9 shaking hands with the 3, which would give me 90 plus 27, or 117, don't forget your label, units squared. So now on this one, we can extend that knowledge to know we would have to multiply our length times our width. We can set it up just like the distributive property. And remember, when you have story problems within a lesson, think about what you've been practicing, and that's how you're going to solve the problem. So since we've been doing the distributive property, we want to set up a problem that requires us to do the distributive property. So in this case, the 12 has to shake hands with the 6x, plus now the 12 needs to shake hands with the 7. 12 times 6x. If you don't know 12 times 6, you come over here. 6 times 2 is 12. 6 times 1 is 6 plus 1. You've got your 72x. Don't get hung up on that multiplication. You know how to go through the steps of multiplying. So just like I did on the side, you can go off to the side and do it. Plus, now we have to do 12 times 7, which gives us 84. And I'm just going to put units squared because I didn't want to forget my label. Now, that's the end of the unit. If you have any questions, please email me at sullivana@milton.k12.wi.us or ask me in class tomorrow.